lecture series on the chapter Periodic Table of an Element. In this video, that is video number 12, we are going to study some of the general properties of group 7A element which is also known as in 17 group element and commonly known as halogens. So I have the element present in group 17 or 7A are fluorine, chlorine, bromine, iodine and astatine. Now out of this, astatine is radioactive. So the first question, we know why these elements, we call it as in halogens. Why these elements are known as halogen. Now in Greek, halos means sea salt. Halos means sea salt and geni means producing. So generally these elements are sea salt former. These elements are sea salt former because sodium, we get sea salt like sodium fluoride, sodium chloride and sodium bromide and to some extent sodium iodide in seawater. So we got chloride, bromide and iodides are present in the form of salt in seawater. That's why they are called as sea salt former or commonly known as halogen. Now, these elements are reactive, so they are not obtained in free state. So mostly because of their reactivity, these are reactive nonmetals. So mainly these elements are found in combined state. Now, all these elements are diatomic molecules. They are diatomic molecules like F2, Cl2, Br2, I2 like that. And they are typical nonmetals. Now, out of this, fluorine is in yellow color gas. Chlorine is a green color gas. Whereas bromine is only non-metal which is found in liquid state. Bromine is one of the non-metal which is found in liquid state and that is red in color. Whereas iodine is violet color crystalline solid. Possessing metallic luster. And astatine, as I previously described, it's a radioactive element. Now generally these elements do not have any free electron. Unlike your metals, this element lacks the presence of free electrons. That's why they are not good conductor of heat and electricity. So these elements are found to be bad conductors of heat and electricity. Apart from that, the melting and boiling point increases with increase in atomic number. That means as I move from fluorine to iodine, the melting point and the boiling point of the substance increases. Now, all these elements, if you look at in their electronic configuration, I got 7 electron in its outermost shell. So these elements readily shows a tendency to gain one electron and get converted into negatively charged ion. So I have a fluorine, which has got atomic number 9, electronic configuration 2,7, will gain one electron and readily gets converted into F-1 ion and completes an octet arrangement, attains a stable electronic configuration of nearest noble gas, that is a neon. Another, I have a chlorine whose atomic number is 17. It has got electronic configuration 287. Now this chlorine also shows a tendency to gain one electron and get converted into negatively charged chloride ion and attains a stable electronic configuration of nearest noble gas, that's an argon. So here you have, they have 7 electron in the valence shell, so readily gains 1 electron and gets converted into negatively charged ion, that we call it as an anion. Now, generally it is been seen that as I move from top to bottom, that means from fluorine to iodine. So halogens are basically reactive non-metal. But as I move from top to bottom, the reactivity goes on decreasing. Unlike your metal, their reactivity for metal increases as I move from top to bottom. But these are non-metal. Please do remember, these are non-metal. So their reactivity goes on decreasing. As I move from top to bottom, the size of an atom increases. So we have a fluorine. Let me have the nucleus of fluorine. And it has got two shells. Okay. And I have a nucleus of iodine. So I have a total fluorine, chlorine, bromine, iodine. So 5 shells will be there. Okay, 3 shells I have for fluorine, 1 for bromine, and next we get for iodine. Now each fluorine has got 7 electron in its outermost shell. So they got 7 electron in its outermost shell. So let me represent those with 7 dots. Here, here also 1, 2, 3, 4, 5, 6, and 7. Here also 1, 2, 3, 4, 5, 6, 7. Now each of this shows a tendency to gain electron. Each of this shows a tendency to gain electron. So when they gain electron, they get converted into negatively charged ion. So fluorine will get converted into F minus 1. So this is fluorine, this is iodine, and this will get converted into I minus 1 ion. But as you observe, it has got smaller size. It has got smaller size. And iodine has got larger size. Okay, so smaller size atom readily gains electron. Smaller size atom readily gains electron. Whereas here, to gain electron, larger size atom gains electron with difficulty. Okay, so here, as fluorine readily gains electron, is a non-metal, so it's a most reactive non-metal. That's why I'm saying here that fluorine is most reactive non-metal, whereas iodine is least reactive, because iodine, because of its bigger size, see, iodine, the size is bigger, the atomic size is bigger, so addition of this electron will not be easy, will not be that much easy. Okay, here the size is smaller. Okay, so the addition of this electron will be easy. Addition of this electron will be easy. As a result of this, fluorine forms F minus 1 ion readily. That's why it acts as a reactive non-metal. Whereas iodine cannot able to add up electron easily. That's why it acts as a least reactive non-metal. That's why it acts as a least reactive non-metal. Then, generally, based on this, we can explain one more property. As we observe, fluorine readily gains electron. So, it acts as an oxidizing agent. See, oxidizing agent is that substance which itself undergoes reduction, that is gain of electron, but helps in oxidation. So halogens will act as a good oxidizing agent because they readily gain electron. But the tendency to accept electron goes on decreasing with increase in size. So as I move from top to bottom, the size of an atom increases. Just now in above example, we have studied that fluorine has got smaller atomic size. So it can readily gain electron. That's why it acts as the strongest oxidizing agent. Whereas iodine, because of its larger size, do not show that readiness to gain an electron. As a result of this, iodine, which is having a larger size, will act as a weakest oxidizing agent, So here I'm talking about in terms of size. If my size is smaller, I can readily gain electron, so I act as a good oxidizing agent. But if I am a larger in size, I cannot gain electron easily. As a result, I'll act as an weak oxidizing agent. So this is what happens with iodine. Because of the larger size, it cannot readily gain electron. That's why it cannot act as a good oxidizing agent. Then I have halogen. They generally show a tendency to react with hydrogen. They show a tendency to react with hydrogen, and when this halogen react with hydrogen, they form corresponding halogen acid. They form corresponding halogen acid. So let me have hydrogen combines with chlorine in order to give me hydrofluoric acid. Hydrogen combines with chlorine in order to give me hydrochloric acid. These are actually gases, but when you dissolve them in water, they are highly soluble in water, so they give you corresponding acid. Then I have hydrogen combines with bromine in order to give me hydrobromic acid, and hydrogen combines with iodine in order to give me hydroiodic acid. Okay. Now, the acid strength, the reactivity of halogen acid follows the order. HF is in weakest, HI is in strongest. So HI is in strongest acid, so it acts as a strong reducing agent. It acts as a strong reducing agent. See here, it will provide you a hydrogen. It will provide you a hydrogen readily. That's why it acts as a reducing agent here. Okay. Then next I am having halogen to react with some of the active metals of group 1 and group 2 elements. That means alkali metal and alkaline earth metal, so as to form corresponding halides. Like I have sodium metal combines with chlorine in order to give me sodium chloride. So to balance this, I'll multiply here by 2, here by 2. Then I have calcium combines with chlorine in order to give me calcium chloride. Now both this sodium chloride and calcium chloride we have studied under chemical bonding chapter. Sodium is a metal, chlorine is non-metal, so the bond formed between them is ionic. So here there is a presence of ionic bond. Here I have ionic bond is present, and here also ionic bond is present. There is a transfer of electron takes place from sodium to chlorine in case of sodium chloride. There is a transfer of electron takes place from calcium to chlorine in calcium chloride. So here halogens do react with active metals of group 1 and group 2A, that is alkali metal and alkaline earth metal, so as to form corresponding metallic halides, and these metallic halides are ionic in nature. Then halogen do combine with some of the non-metals. Halogen do combine with some of the non-metals and results in formation of corresponding compound which are covalent in nature. So let me have phosphorus combines with chlorine in order to give me PCl3. Okay, so I have 4 phosphorus here and 6 chlorine. So I can write down this particular in terms of PCl3. It's called as phosphorus trichloride, that is covalent compound. Nitrogen combines with chlorine in order to give me NCl3. It's called as nitrogen trichloride. It's called as nitrogen trichloride. This is also a covalent compound. So here, whenever you have halogen, it reacts with non-metal. It results in formation of corresponding compound, and those compounds are covalent in nature. Thank you for watching.